Scientists baffled as Mars is mysteriously spinning faster and faster. Data from the Mars InSight lander has also revealed how much the planet wobbles as a result of its liquid core sloshing about. Mars' rotation is slowly but inexorably increasing, shortening the length of the planet's day by a fraction of a millisecond every year. This is the conclusion of the researchers who studied data collected by NASA's Interior Exploration using Seismic Investigations, Geodesy, and Heat Transport InSight lander, which spent 4 years studying the red planet before running out of power last December. By sending a radio signal from Earth into InSight's radio apparatus and back, the team were able to determine exactly how fast the planet is rotating and how this changes with time. Alongside revealing Mars' rotation to be accelerating by 4 milliarc seconds per year, the data also revealed how the planet is wobbling thanks to sloshing molten metal in its core. The cause of the acceleration is not clear, although the researchers think it may be related to ice accumulation at the poles or land masses rising slowly after being buried by the ice. And these shifting masses distributions could cause a planet rotation to speed up, much like ice skaters can spin faster by drawing their arms inward. And the NASA, as the study has undertaken, the planetary geophysicist Dr. Bruce Bernard of NASA's Jet Propulsion Laboratory in Southern California and his colleagues said, "It's really cool to be able to get the latest measurement and so precisely. I've been involved," he says, in efforts to get a geophysical station like InSight into Mars for a long time. He says results like this make all those decades of work well worth it. The study relied on radio data from one of the InSight's instruments, known as the Rotation and Interior Structure Experiment, or RISE for short. RISE, which incorporates both radio antenna and a transponder, is part of the long tradition of NASA's Mars landers using radio waves for science, including both the twin Viking landers of the 1970s and Pathfinder of the 1990s. InSight has advantages over its predecessors, though, in the form of more advanced radio technology and upgrades to the antennas that make up NASA's deep space network here on Earth, giving its data 5 times the accuracy of those from the Viking landers. The researchers explained that they're able to calculate Mars' rotation from the signal bounced back from InSight thanks to the Doppler effect. Likely familiar from high school physics, this is the same phenomenon that causes the sirens of passing ambulances to change pitch as they grow closer and then pull farther away. Planetary astronomers Dr. Sébastien Lemestre, also of the Jet Propulsion Laboratory, is RISE's principal investigator, and he said, "What we're looking for are variations that are just a few tenths of centimeters above the course of the Martian year. It takes a very long time and a lot of data to accumulate before we can even see these variations." In fact, the team explained they examined 900 days worth of data collected by InSight. Part of the time-consuming analytic process involved eliminating sources of noise that would otherwise distort off the data, such as variations in the moisture in Earth's atmosphere through which the radio signals must pass and similar fluxes in the solar wind. Dr. Lemestre concludes it's a historic experiment. "We have spent a lot of time and energy preparing the experiment and anticipating these discoveries. But despite this, we're still surprised along the way, and it's not over, since RISE still has a lot to reveal to us about Mars." And the findings of the study were published in the journal Nature magazine. This is by Ian Randall on Express UK. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.